Graphic representation. In this module, we will discuss about the graphical representation. A graphical representation helps us in understanding given data at a glance. We know how to represent the data through bar graphs, histograms, and frequency polygons. Let us now represent a cumulative frequency distribution graphically. To represent the data in the table graphically, we mark the upper limits of the class intervals on the horizontal axis, x-axis, and their corresponding cumulative frequencies on the vertical axis, y-axis, choosing a convenient scale. Let us now represent this data graphically. Plot the upper limits of the class intervals on the x-axis and their corresponding cumulative frequencies on the y-axis. Let us now plot the points corresponding to the ordered pairs given by upper limit, corresponding cumulative frequency, that is 10, 5, 20, 8, 30, 12, 40, 15, 50, 18, 60, 22, 70, 29, 80, 38, 90, 45, 100, 53 on graph. Join the points. The curve we get is called cumulative frequency curve or an ogive of less than type. Now we will draw the ogive of the more than type. Let us take this data. Here 0, 10, 20 and so on up to 90 are the lower limits of the respective class intervals 0 to 10, 10 to 20 and so on up to 90 to 100. To represent the more than type graphically, we plot the lower limits on the x-axis and the corresponding cumulative frequencies on the y-axis. Then we plot the points lower limit, corresponding cumulative frequency, that is 0, 53, 10, 48, 20, 45, 30, 41, 40, 38, 50, 35, 60, 31, 70, 24, 80, 15, 90, 8 on a graph paper and join them by a freehand smooth curve. The curve we get is a cumulative frequency curve or an ogive of the more than type. Now let us see how to obtain the median from these cumulative frequency curves. One obvious way is to locate n by 2 is equal to 53 by 2 is equal to 26.5 on the y-axis. From this point, draw a line parallel to the x-axis, cutting the curve at a point. From this point, draw a perpendicular to the x-axis. The point of intersection of this perpendicular with the x-axis determines the median of the data. There is another way of obtaining the median. Draw both ogives, that is, of the less than type and of the more than type, on the same axis. The two ogives will intersect each other at a point. From this point, if we draw a perpendicular on the x-axis, the point at which it cuts the x-axis gives us the median.